So welcome to COP29. My name is Kingley, Head of Policy and Industry Engagement at the World Nuclear Association. I'd like to welcome you to the Net Zero Nuclear Pavilion. I'm delighted to moderate this panel session on energy users, how partnership between nuclear energy and high energy users can decarbonize the entire economy. Today is the Energy Day at COP. Rightly, that the attention is focused on urgent need to decarbonize all areas of our energy system. Achieving net zero require decarbonizing energy-intensive industry like large energy users, process sectors, and these sectors are the most challenging to decarbonize with the current highly reliance on fossil fuel. At the last COP28 in Dubai, the first global stocktake, we saw 198 signatory countries call for the accelerating the deployment of low emission energy technology, including nuclear power, to deep and rapid decarbonization, in particular hard to abate sectors such as industry. This represents the first time that nuclear energy has been formally specified as one of the solutions to climate change in the COP agreement. Energy-intensive industry such as steelmaking, chemical production, data centers are the backbone of modern societies. These industries require vast amounts of energy to operate, and their energy consumption is only expected to rise with the technological advancement and increasing global demand. Demand for clean energy for these energy-intensive industry we intend to increase. IEA estimate that consumption from data center, artificial intelligence, and crypto sector could be doubled by 2026 compared to 2022. So the significant growth in these electricity demands from data center contributed to recent announcement by the US tech hyperscaler like Amazon, Google, and Microsoft in their investment in nuclear energy. Also, in August this year, China have given approval for the Shuwei nuclear power project to be built by CNNC to provide industrial steam and power for the Lingangang petrochemical process. The project will be the world's first nuclear power plant that couple high temperature reactors with traditional pressurized water reactors. Combining the steam from 2 large Halong nuclear power plants with 6 high temperature gas cooled reactors. So we will explore in this session the use of nuclear energy beyond giga scale electrical production, and we'll discuss nuclear application in industrial process, digital technology services, and we'll explore what is required and how nuclear can help in these sectors. So therefore, I'm delighted that we have a panel of experts from across the sectors and region. Caroline, from your point of view, from in France and Europe, so what are over to you in terms of how do you see the development and the use of nuclear for energy intensive?
All right, thank you. Very delighted to be here. So I work for EDF, which is a world leader in low carbon electricity generation, with an objective of building a net zero energy future with electricity and innovative solutions and services. In 2023, EDF Group produced 467 terawatt hours of electricity, 93% of which was decarbonized. And as a consequence, the carbon intensity was one of the lowest in the world, with 37 grams of CO2 per kilowatt hour, which is a much lower, 6 times lower than the average European utility. And regarding like what's happening in France and Europe, so in France, a very large nuclear program was built in the 80s and the 90s, which led out to phasing out most of the fossil fuels for power generation. And EDF has an extensive experience in operating those plants, and it's also a major player in nuclear new build across France, but also the UK and Europe. It's developing EPRs, which are large-scale reactors, but also smaller-scale reactors. And in the context, net zero by 2050, the different countries are planning their roadmap. In France, a large program has been announced with 6 EPRs and a further 8 as an option, along with the large-scale development of renewables. Several other countries in Europe are also considering nuclear new build to reach their 2050s targets, and EDF is working with them. The European Commission is setting in new industrial alliance that aims to accelerate the development, demonstration, and deployment of small modular reactors in Europe, so that we can reach by the early 2030s. And it's also promoting the collaboration between different European stakeholders through joint research projects. And on hybrid reactors, the R&D of EDF, which I'm a member of, participates to several projects, the Tandem or the Gemini 4.0, which aims to facilitate the safe and efficient integration of SMRs and also build a low-carbon future for industry.
Thanks, King, and thank you very much to my other panelists. Yes, indeed, I work for Accenture, representing the World Economic Forum today, whom we've been working with over the last year, along with partners from across the industry, to develop a collaborative framework for accelerating advanced nuclear and, in particular, SMRs. In terms of how nuclear can play its part to decarbonise, in particular, heavy industry, I think, as Jeff said, the requirement for baseload and a 24/7 baseload is particularly important, and particularly with nuclear being a clean energy source, it is becoming increasingly important overall. Globally, there are now something like 11,000 data centers, and that is an area that is obviously is growing. And with the advent of AI, we're seeing significant growth now expected, and that is driving interest in both SMRs, but also traditional large nuclear reactors. To put some scale on that, a data center today might require somewhere between 30 and maybe 150 megawatts. But as we look to decarbonize heavy industry, which I would include data centers in that, the development of AI could mean that we get gigawatt data centers, and that's going to need significant amount of clean power, additive clean power, if we're not going to put strain on the already installed base. As we know, nuclear accounts for around 25% of global clean energy, and around 10% globally in terms of energy output. And to maintain that, whilst also accommodating for this decarbonisation in industry, we're going to need to see significant investment to make that possible. So certainly, nuclear is a critical enabler to decarbonisation, and in particular, heavy industry and new technology industries. The same can be said in the UK. Obviously, we're very much underway now with Hinkley Point C, and Sizewell C is quickly to follow. And there's a lot of developments, whether it's with Great British Nuclear and via the government, to continue that drive. And we hope very much that nuclear will form a critical component to the energy mix in the UK.
You mentioned about the demand for electricity, clean energy from data center, particularly from AI. I'm sure we will touch on that further during our discussion. Jeff, well, first of all, I would say congratulations, to the recent announcement by Google to invest in Kairos Power. Can you talk a little bit more about the importance of 24/7 carbon-free energy, and particularly from a perspective of an end user point of view?
Yeah, absolutely, King. Thank you. It was a big accomplishment for Kairos, and we'd like to thank for Google as well to execute the world's first multi-plant development agreement from a commercial customer. And I think that was a big week for others in the industry as well. You saw Amazon investing as well. And not long before that, you saw Microsoft working to reopen 3 Mile Island. So there's a lot of demonstrated need from that customer segment alone now for 24/7 clean energy. I think we've on a relative basis as a global economy, and especially within the U.S. as well, where I sit, we've seen relative stability in energy demand over a long period of most of our history. Now, on a relative basis, that's radically changing. There's a paradigm shift that grids and utility operators are having to cope with, in just an inability to meet the demand of data centers and other energy consumers that are coming into play. And so we're at a point now where large energy consumers who once had the ability to sort of enter a market and be incentivized to do so are now being almost forced to bring their own energy with them in order to deliver the core businesses that they're seeking to grow and expand. And so the existing energy resources we have, conventional and renewable, will continue to play an important role because we'll need a portfolio. But increasingly, what we'll need is incremental 24/7 of energy to play going forward.
We learned obviously the demand for clean energy from you, Jeff. Now, maybe if you can talk about the competitiveness of nuclear, how do the cost and contract term impact on coupling nuclear with this application? What are the opportunities and challenges, in terms of on the economics?
Yeah, I think that's it's an important question, because if we're candid about the history of nuclear, there are a couple things that are true about much of that history. One, there's a great history of safety and demonstrated ability to produce carbon-free electricity reliably and safely. That's important. But there's also a history, especially with recent developments, of projects being overcost and beyond original schedule, to the order of billions and almost measurable in decades. That's very difficult for any customer to be able to plan around. And those are things that have to be addressed with this next generation of nuclear, and or the bringing of prior facilities back online. And so within the SMR category of nuclear, there are different strategies that companies are taking. What we're doing at Kairos Power, I can speak to specifically, is there are two principles that we feel are imperative to our ability to improve both cost predictability and schedule predictability, to drive towards certainty of both of those. And of course, we're not certain what we're going to be doing in 2 minutes from right now, absolutely, but to drive towards certainty, to better understand costs and have a better handle on schedule, and not only for ourselves, but for our customers and the utilities with whom we're interfacing, for them to have a similar confidence, so that we can have planning confidence and a willingness to plan around the future of nuclear. Because without those plans, without those commitments, and without the broader inclusion of those stakeholders being able to have confidence, we'll be stuck in an inability to move forward. So that's all part of being, for this sector to be competitive going forward, helping you improve that confidence. And so the way we are seeking to address that at Kairos is largely in two parts. One is through an iterative development process. And so that means that we are building now. We're doing multiple iterations of increasingly prototypic builds. So plants, so large structures that are increasingly similar to what will be our power plants. So last year we built and operated at the scale of our first reactor, a non-nuclear facility that included a surrogate fuel pebble. So our fuel source is triso fuel. It's a sphere. It looks like a carbon ping pong ball. And that non-nuclear system had 30,000 of those pebbles within it. It also operated at temperature. It operated at 650, almost 650 degrees C, which is approximately our operating temperature. So as we had those physical attributes and had that system running, we were able to observe how that worked, observed the construction process, and not everything went perfectly. Nothing went horribly wrong. It was very successful. But there are a number of levers that we can look to address to optimize our next build. So that is one of 3 non-nuclear builds that we'll build before we deploy our first reactor. And then we'll build 2 demonstration reactors before we scale commercially. And it's the iteration of those builds and the lessons learned from those builds that will help us to demonstrate an increasing understanding of cost to drive toward cost certainty and schedule. It's like practice, whether someone plays a musical instrument or a sport. We rarely go to our first competition ready to go. We don't want to go to our first customer and say, here we go. It looks good on paper, and now we're going to build it for you. I think we're finding that it's really important to build and allow those customers to follow that along the way. So it looks like we might have, I don't want to take too long in answering this point. There's a lot more I can cover, but it looks like we may have folks back online again. Is that? Okay. Thank you, King.
Thank you, Jeff. I totally agree with you. We learn by doing, and it's important that we continue have project and to get our experience from that. So over to you, Julian. Just a note that recently the World Economic Forum published a report on nuclear energy. Can you tell us a little bit about that and why World Economic Forum started a nuclear initiative?
Yeah, thank you very much, King. So yes, the World Economic Forum, they've started this initiative. They're committed to supporting transition to secure, sustainable and equitable energy system, in addition to other clean energy sources such as solar and wind. They recognise that nuclear actually has a key role to play in achieving the transition. For this reason, the WEF has partnered with stakeholders across the nuclear sector, including developers, utilities, governments, regulators, etc., to build out a framework. And it's applicable to SMRs and nuclear, but also actually to other innovative technologies that could also help in decarbonisation. The framework itself is aimed to provide guidance through 9 key priority areas. So, for example, evolving energy policy, developing talent, and building out a supply chain that a government or a geography needs to consider to put in place if development of nuclear power is to be successful. So it's not necessarily that WEF is in any way has changed a stance. It's more of the recognition of the importance that nuclear has in that clean energy market.
Julian, compliments to you and the team at Accenture and the World Economic Forum for helping to drive publications like this from trusted advisors like Accenture. So these are, organizations look to proven consultancies to help them advise where they go, and having these instances of education out there will hopefully help others continue to ramp up the learning curve and be there for the industry as it grows.
Thank you. Hopefully, Caroline, you can hear us and got stable connection. Just go back about perhaps provide EDF's perspective. So can you just talk a little bit more about use of nuclear beyond electricity and how nuclear can produce other low carbon energy vectors?
Thank you very much, King. Yeah, so most of the nuclear plants produce electricity. However, about 15% of the plants produce or have produced more than electricity, because before generating electricity, a nuclear power plant produces steam. The steam is then used to generate electricity, and a fraction of that steam can be removed and used to heat up or possibly vaporize another fluid. And traditionally, when cogeneration was installed, it was used for heating applications, such as urban heating or process heat, or a combination of both. And most of those cogeneration units were installed in Eastern Europe, in Russia, but also in Switzerland. And the site of Goes 1979, then it was upgraded to include heat delivery for a small district heating network. And more recently, a second paper mill was built next to the plant to take advantage of that low carbon heat. And so this is one example. So the paper industry is well suited to couple with light water nuclear reactors. Other appropriate industries include also the food industry. You have petrochemical industries, chemistry industries for some of their processes. And other possible uses are also seawater desalination that can benefit from nuclear coupling. And for example, in Kazakhstan and Japan, it has been producing fresh water. That's when we talk about what, turbine heat. So that's like high temperature heat. Another way that we can couple the electricity generation. And nuclear power plants produce low-grade heat in large quantities. And that can be used for sporting facilities, for buildings, for heating buildings, and also greenhouses in France. And another project that's quite emblematic is in Dunkirk in France is a port harbor where there is an 6-reactor power plant, sorry, and it's used to feed the LNG terminal in Dunkirk, and it's allowing with this hot water to save 400,000 tons of CO2 a year. So this is like some of the examples that are, yeah.
Thank you very much for that, Caroline, and all of the wide use of energy. Maybe to carry on with you, you mentioned hydrogen as a perspective. Can you talk a little bit more how nuclear can be a player in producing low carbon hydrogen?
Yes, of course. So yeah, so some of the applications for those for the heat can be a nuclear, can be a hydrogen. And so when we look at today, most of the hydrogen is produced with fossil fuels, and low emission hydrogens is representing about only 1% of the total produced hydrogen. And we can produce low carbon hydrogen with water electrolysis. And so this means that we can use energy to split the water molecules. And we have different technology. We can use low temperature electrolysis. So that's where we actually electrolyze water as a liquid. And we can have high temperature electrolysis. This is where we electrolyze water as steam. And so for both technologies, nuclear can be a player because they are energy intensive. So, and for that, having 24/7 low carbon electricity is an asset. So when we look at low temperature electrolysis, so we need only electricity. When we look at high temperature electrolysis, then we need to electrolyze steam. And this is where we can use both the electricity and the heat from steam from a nuclear plant through an exchanger, so that we can heat up the water that will then be used to produce the hydrogen. And the high temperature electrolysis has the promise of having higher energy efficiency, where we could save about 20 to 30% energy when we produce hydrogen through this process.
Now, Jeff, we talked quite a bit in this session about the use of nuclear to provide power to data centers. So what makes SMR and nuclear unique, well suited to power nuclear data center compared to other energy sources?
Yeah, data centers will require an energy source that's robust and available. And so 24/7 is required, and carbon-free, clean energy is typically mandated as well. And so when you look at a resource that can provide both and complement what renewables have initially done to help reduce the carbon intensity of the energy used by those customers, I think you've got a good fit, right? And the ability for nuclear to scale. We were talking about the size of data centers that we're seeing today, and we're being approached by customers who are looking at there's a data center in the US that's under development for over 3 gigawatts. which is larger than some of the countries present here today are probably demanding. It's incredible. It's quite incredible. So I think there's a good fit for that reason. You can also look at the density of power generation, other factors like that, but it's a very good fit for that application.
Thank you, Jeff. And obviously, we had heard about the use of nuclear for various different applications, data centers, and production of hydrogen. Over to you, Julian. Particularly you mentioned about the World Economic Forum framework. It notes about transforming project delivery, and it's important to accelerate SMR development. Can you give an example what that would look like?
Yeah, absolutely. So I think it's understood that particularly in perhaps North America, Europe, that typically large-scale nuclear deployments have faced various challenges, including high costs and elongated construction times, sometimes regulation hurdles as well. We know that can be that actually there's experience globally that has shown that the development and construction of nuclear power stations can be done cost effectively. For example, the Baraka plant in the UAE, etc. But the complexity generally of a nuclear energy project can cause fragmentation between the owners and operators and the various EPCs that are involved in construction. So one of the areas that we spoke about in the framework is the need to address the unequal distribution of risk and management between the different organizations. So coming up perhaps with a creative approach to a new development organization, for example, that could integrate and accelerate program and project delivery in a particular market or region or across regions is one way that could help address some of the concerns that we have. Obviously, it's also anticipated in SMRs that modular construction and building in closed environments in factories, etc., is another sort of technical solution to meeting some of those challenges. So there's a number of different things that could certainly address the concerns, and the framework has picked up on that. I'd also add that during construction, we would recommend things like extensive use of digital tools and such to allow full collaboration across that integrated supply chain. We've seen huge improvements of that in the last few years on the nuclear construction program, certainly that we've been involved in. But a continuation of that trend is going to be really important as we look to build power plants on time and on budget. And particularly managing things like configuration control during the construction itself that can often cause problems when moving towards commissioning activities.
It's really interesting with the World Economic Forum framework providing sort of insight how to accelerate the deployment of SMR. Maybe I would like to draw the discussion to a close.